This video explains how to calculate transformer power ratings of electrical loads. Moving on, supposing the load requirement of a particular building is given as follows. The red phase load denoted by RL is in VA, and the yellow phase load denoted by YL is also in VA. Blue phase load BL is in VA. VA means volt ampere, and it takes care of the situation where power factor not being unity, that is not being 1. If it is involved, it takes care of it. So that's why the power rating is usually calculated in VA, which is the unit of apparent power. Alright. If the rating of the transformer for the building is required, then transformer power rating determining load, that is the load that determines the rating of the transformer, is 3 times the highest phase load. We look at when the loads are given in values, that is as figures, we look at the highest and multiply the highest load by 3, that is the phase load. The highest phase load, we multiply it by 3, and that is what we form the determining load for the rating of the transformer that will be required, and not the algebraic sum of the phase loads. This is the algebraic sum of the phase load, RL plus YL plus BL. It is not this, emphatically not, and that's why I'm putting this cross mark. That is that indicates that this one is not the right mathematical statement, but this is the right one. That's why I take this one. All right. For the purpose of understanding, we use one example to explain everything clearly. Here is the example. The power requirement of a complex at 230 volts 50 Hz is given as follows. Red phase load 75 kVA, yellow phase 65 kVA, blue phase 50 kVA. Practically, we can come across an unbalanced load system like this. Practically, it's possible, especially if the designer is not aware of the fact that the load system is not balanced, and if the person to size the transformer doesn't have access to the solution or to the design, has to do a redesign or to adjust the loading system. So he has no option but to go ahead. So going forward, the questions are: calculate the phase current, hence or otherwise determine the transformer power rating for the complex. So we move on to the solutions to the problem. This is the solution to the A part. Red phase current denoted by RR is equal to 75,000 VA divided by 230 volts, and that's the answer there, 326.1 ampere. So, and similarly, these are the answers for the remaining part of the question. The current in the yellow phase is this, that is 282.6 ampere. Blue phase current is 217.4 ampere. In doing this calculation, the power must be in VA, not in kVA, because the unit is VA since the voltage is in volts. Alright, and that is the solution to the A part. Now, coming to the B part, if you wrongly think that transformer rating determining load is equal to the algebraic sum of the phase loads, then you will wrongly select 200 kVA as transformer rating. And to prove that 200 kVA is wrong, 200 kVA current at 230 volts and 50 Hertz is equal to 200,000 VA divided by 3, and then the results to be divided by 230 volts. So that is 200,000 VA divided by 3, and then the result to be divided by 230 volts, giving us 289.9 ampere, which is less than IR, which is 326.1 ampere in part A. And this 326.1 ampere in part A is the power requirement current for the red phase. So, and this is meaning that 200 kVA transformer cannot withstand 326.1 phase currents. Otherwise, the windings will get burnt. So, what is happening here is that clearly 200 kVA transformer is not the right selection. So, we move on and see what the right selection will be. Now, looking at the right concept, if we use the right concept, the transformer power rating determining load is equal to 3 times the highest phase load, alright, and it is equal to 3 times 75 kVA, which is 75,000 VA, and this is the result. And the closest higher transformer standard rating is 300 kVA, because when we look at 225 kVA, one doesn't go lower than this. One will look for the next higher transformer rating, and that is 300 kVA. So hence the right transformer power rating for the complex is 300 kVA. And one can check, and that one can be done as follows. 300, we can calculate the phase current of 300 kVA transformer, and this is the answer to that, 434.8 ampere triple phase, and that is greater than 326.1 ampere, which is the highest current to be drawn by the red phase load as given by the question. Alright, and that means that 300 kVA transformer can withstand the highest load current of 326.1 ampere in part A. That is the phase current that we calculate in part A, and that is the highest current that we can get from the given power rating or power requirement of the complex. Therefore, in conclusion, 300 kVA is the right transformer rating for the complex, just as we said earlier. So, thanks for watching, and if you find the video useful, please consider subscribing to my channel. Thanks for watching.